Session 2010, so determination of the resistance of a resistor. We intend to determine the resistance R of a resistor, so we connect the circuit represented in figure 1 that's formed of an ideal generator of electromotive force E equal to 5 volt, and a resistor R where we have a capacitor of capacitance C equal 33 microfarad. We intend to charge the capacitor. To what position 1 or 2 must then K be moved? So in order to charge the capacitor must have a generator, then it must be connected to position 1. So the circuit reaches a steady phase. After a certain time, give them the value of the voltage UAB across C and that of the voltage R. So in order to find the voltage after a certain time, this means at the end of the charging. So at the end of the charging, we have UC equals to maximum, which means it's equals to E, where we have it is equal to 5 volts. And we also need to find the voltage across the resistor. So according to the law of addition of voltages, we have U of the generator is equal to U of the resistor plus UC. This is E, and at the end we have UC, this is equals to E, so plus UR, which means that UR is equals to 0. Discharging of the capacitor. Now draw a diagram of the circuit during discharging of the capacitor and show on it the direction of the current it carries. So we had, before we had, this is plus, and this is minus. This was the generator, so that's it. And this means A becomes positively charged while B becomes negatively charged. So it's like this. Here we go. This is the resistor. This is A and B. This is positively charged and this is negatively charged. So, and show the direction of the current, then this will be the direction of the current. Part 2, derive the differential equation UC during the discharging. So according to the law of addition of voltages, we have U of the capacitor is equals to U of the resistor, which means UC is equal to R times I. But in the case of discharging, I have I equal minus dQ over dt, which means minus C duC over dt. And I substitute, then I'll get UC equal minus RC duC by dt. I bring this one here, so we'll get UC plus RC duC by dt is equal to 0. This will be our differential equation. And we can also divide by RC, so we'll get duC by dt plus UC over RC is equals to 0. The solution of this differential equation is of the form UC equal E minus T over tau, where tau is a constant. So determine the expression of tau in terms of R and C. Since it's a solution, this means to verify the differential equation, plus UC over RC is equal to 0. So let's now we have UC equals E minus T over tau. So let's now the derivative. And by doing the derivative, we'll get E minus 1 over tau, E minus T over tau. Now, هيدي حنعملها substitution differential equations, which means that minus E over tau, E minus T over tau, plus UC اللي هي exponential over RC is equal to 0. And then we take a common factor. So should be now minus 1 over tau plus 1 over RC is equal to 0. This means that minus 1 over tau plus 1 over RC is equal to 0. يعني يطلع عنا tau equal to R times C. Part B, determine the value of UC at the instant T1 equals to tau. So in order to determine the value of UC at T1, I'll determine, this means I must verify. So at T equals to tau, we'll substitute UC equal E minus tau over tau. So this means it's equal E to the power E minus 1. واللي حيطلع معنا the answer is equal to 0.37 E. Now, we continue, and it's equal to 0.37 times 5, which will give us 1.85 volt. Part C now, give in terms of tau, the minimum duration needed at the end of which the capacitor is practically totally discharged. This is at T equals to 5 tau. So we continue, derive the expression of len UC in terms of, so we have UC equal E which means that len of UC is equal len E. واللي هي هيدا the form len A times B بتصير len A plus len B. This means len UC equal len E plus len exponential minus T over tau, which means that len of UC is equals to len E minus T over tau. Then this will be the equation in terms of time. Part E, the diagram of figure 2 represents the variation of len UC as function of the time. Referring to the graph of the figure 2, determine the value of R. Now, in order to determine the value of R, we must find the value of the slope. Since if we notice here, this is the equation. And height is of the form y equal, this is here, A, so it's A, T plus B. Means the part اللي فيه tau equal to RC هو slope. So this means لازم أطلع slope قد بتساوي. So A equal to y final minus y initial, which is 0 minus 1.61 over 53 minus 0. But here it's in milliseconds, so times 10 power minus 3. Then we'll get the slope is equals to minus 1 over 1.61 over 0.053. Now, but A, we already said that A is equal to minus 1 over tau. So هيدي كلها equal minus 1 over R times C. And we already have C, so can minus C will given. This means that R is equals to minus and minus. So it's equals to 0.053 over C times 1.61, which will be equals to 10 to the power approximately 10 to the power 3.